welcome back, guys. So let's start. I just realized that the thing wasn't working well. So today I want us to talk about vectors. Okay? And this particular question is BECE 2003, question 18. Okay? So BECE 2003, question 18 says, find if vector A equal 2, 4 and vector B equal negative 2, okay, negative 3, 2. Find 2A minus B. So to solve this quickly, we want to understand multiplying a scalar by a vector. What do I mean by a scalar? If I have vector BC and there's a number in front of this vector, this is called a scalar, okay? This is called a scalar. Now this scalar is going to multiply each member of this vector, so it means there's going to be AB and then AC. Okay? AB and AC. So this is how we multiply a vector by a scalar. We will need it when we are solving this part of the vector. Without wasting time, let's spring into action our solution. So solution basically will be, we have to write the expression. This is the expression. We have to write it down. So it becomes 2A minus B, which implies that 2, which is our scalar, multiplying vector 2, 4, minus, the operation sign here is minus, so minus into brackets negative 3, 2. Okay? Now, as I've explained earlier, that if we have this scalar, this is how we are supposed to solve it. So it's the same thing we are going to do here. So let's move on. It means that 2 multiply 2 and then 2 multiply 4. Okay? And then we have our subtraction. So negative 3, 2. Remember with vectors, they have brackets, and in math, brackets means multiplication. So when you identify, you realize that we have these two negatives here. So you'll be wondering how you are going to solve it. This becomes positive because negative, because of the bracket, negative times negative will give us a positive. Okay? So let's first simplify this side. Simplifying this side, this will give us 4. 2 times 2, 4. 2 times 4 will give us 8. Okay? Then we'll bring our operation sign. But before we bring our operation sign, we should try and see if we can expand the side of the vector. Okay, so expanding the side of vector means we would have addition. Okay, we'll have addition in there. But what we can also do is to let's write it again, and then we can go ahead and say 4 minus into brackets negative 3, and then what? 8 minus 2. Okay, so we are bringing the vectors together to be able to do find the operations of a vector. You bring them together. That's the goal. Okay, but because of the 3 has a negative, we are putting it into a bracket. Okay, that's how come this 3 is still in a bracket. Okay, so having this, remember bracket means multiplication, so this will be changed to addition. Okay, so that will give us 4 plus 3, and then 8 minus 2. Solving that will be 7, 6. Remember, vectors are not fractions, so you are not supposed to write a fraction bar in your vector. Don't, as much as possible, don't be tempted to do that, because once you do that, the whole thing is wrong. You have 1 minute to copy, and then we'll move to the next question. Our next question is going to be about polygons, okay? Polygons. So there'll be a diagram that we are going to use to find the variable in the polygon. You have 30 seconds more to finish copying. So whilst you wait, please click on the subscription button. It's very, very important. Like the video. The more you like the video and the more you subscribe, the more this video gets attention, and then everyone gets attracted to it. So if you have not subscribed, please subscribe. If not liked this video and my other videos, please try and like them. Again, too, you can go to Think Academics and register. thinkacademics.com is my personal website where I have courses, BECE math courses, science math. We are now migrating the courses and the syllabus onto the website. So hopefully by the end of next week, it should be ready. We have free courses, we have paid courses, we have quizzes. So quizzes are timed, and they are very, very interesting. I think it's a great platform to learn. So if you are watching here and you've not registered, just go. Registration is free. Just go register, and I have a giveaway package for the first 20 students who register on the website. So please subscribe, please like the video, and let's move to the next question. The next question is also BECE, so polygons, okay? Polygons, and it's also BECE 2003, question 19, okay? Then it says find the value of x in the polygon below. A polygon basically is a plane shape with straight edges. Plane shape, okay? This is a solid shape. So a polygon is a closed plane shape with straight edges. So it means that a circle will not qualify as a polygon. Okay, but this will be a polygon. So when we think about all the plane shapes that are closed and they have straight edges, obviously the very first one will be a triangle. Okay? Then followed by the quadrilaterals, and then we'll move to pentagon and all those shapes. Okay, so let's do the drawing. This is the drawing. Yeah, so this is the drawing. We have x, we have 5x, we have 3x, we have 2x, we have 4x. Okay, so they are saying we should find the value. Now when you look at this closely, we need to identify where these angles are. they are inside the polygons. So if they are inside the polygons, then we are going to call them interior angles. Okay? And then if we need to find them, we can find the sum of interior angles, and then we'll sum all this and equate it to the sum of interior angles. Why do we need to find the sum of interior angles? Because the sum of interior angles, all we need is to know the number of sides of that particular polygon. Okay, so sum of interior angle of a polygon is, so the sum represents the s representing the sum, and then the formula is into bracket n minus 2 times 180 degrees. Okay, n minus 2 times 180 degrees, where n is the number of sides of the particular polygon. So this particular polygon, if you should count, we'll have 1, 2, 3, 4, 5. So the polygon will have 5 sides. So we can boldly state that where n equals what? 5. So we'll fix in 5 minus 2 times 180. Okay, times 180. 5 minus 2 times 180 will obviously give us 3 times 180. 3 times 180. And then when we solve that, we're going to get 540 degrees. Now 540 degrees basically is the sum of interior angles. So it means that this 540, if I decide to sum all these angles, should be equal to 540, this 540. Okay, what do I mean by sum? If I decide to add all these angles, it should be equal to 540. So we can boldly write 2x plus 3x plus 4x plus 5x plus x equals 540. Doing our summation, 2, 3, 4, 5, and 1 will give us 15x equals 540 degrees. Okay, now we need a value of x, and there's 15 here, so we'll just divide both sides by 15, and this goes away. Now we have 540 divided by 15, and that should 5. We are using 5. Okay, so that should give us 36. Okay, that should give us 36. Let me write the 3 well so that you can all see. That should give us 36. So our answer is 36. It basically means that this is just x. So it means this angle will be 36. This angle will be 4 times what? 36. This will be what? 5 times 36. Okay? This will be 3 times what? 36. But that's if they tell you to find a particular angle, and then that's when you need to do this. But if they didn't tell you to find an angle, and then you can just state your answer like that, and then you would move. Okay? So we want to continue we want to look at some other past questions. And then the past question we want to look at is mainly, okay, so 1 minute to copy quickly, 1 minute. So the past question we want to look at now is from BECE 2003. Okay, BECE 2003, and it has to do with angles. And then from there we'll look at the same BECE 2003. We'll look at right angled triangles. Okay, right angled triangles. Are we okay? So I think our 1 minute is up. Let's move on. Moving on. Moving on. BECE 2003, question 34. We have this angle question. And we have y here, we have x here. And it's very simple and straightforward. They are saying that what is the relation between x and y? In terms of principle, what is the relation between this x and then this y? Okay? Remember, you will have arrowheads here. Now, this angle is sitting on top of this line. This angle is also sitting on top. Alternating angles basically are angles that are found when a Z shape is made. Okay, so this angle and this angle and this Z will be alternating. Okay. Okay, so that's a little revision. Let's take another angle question, which is the question number 36. Same BECE. Same BECE, question number 36. We have this beautiful diagram. We have here to be 56 degrees. We have here to be 72 degrees. Okay, 72. I don't know if you can see. Let me write that well. 72 degrees. Okay, and then we have here to be f. Now they are saying we should find the value of f. Find the value of f. So angle f. To find the value of angle f, it's a bit longer. The second one is a bit straightforward, but it all depends on you whether you are going to be able to remember this principle I just made mention of. Two interior angles, the sum of two interior angles is equal to the opposite exterior angle. Are we okay? So let's move on. Moving on, we want to look at right angled triangle. Right angled triangles. But before we move on, 1 minute to copy as usual. 1 minute to copy. So copy quickly. If you are using a phone, you can take a screenshot of it so that later you come back to it. So let's move on. Now moving on, we have this diagram, and this question is also question 31. Okay, BECE 2003. BECE 2003, question 31. We have this beautiful right angle. Math is beautiful. You need to enjoy it. To be able to be good at it, you need to enjoy it. So we have this, and we have 5 centimeters here. We have 13 centimeters here. They've been labeled as Y, Z, and X. Okay? And they are saying we should find X, Z. Now for those who are confused, the bar that is by this XZ shows that we should find the magnitude. The magnitude is the same as find the length. Okay? That find the length. Are we okay? So finding the length, we need to apply a theorem. The theorem says that, okay, let's first of all understand this. Let's do a quick review. If I have a right angle triangle, I need to know the labelings of the right angle triangle. Okay? So this angle here will help me do the labeling. A right angle triangle basically is a triangle that has a 90 degrees angle in it. Okay? So these are 90 degrees. This box always determines or shows that your angle in there is 90 degrees. Now, using this angle, which is opposite the 90 degrees, will help us name this right angle triangle. It's not our main topic for today, but I'll just rush through it quickly so that those who don't have knowledge about it will get a bit of knowledge about it and understand what we are about to do quickly. So using this as our reference point, the angle there as our reference point, okay? This angle is opposite this line, so this portion is called what? Opposite. Okay? Now, the line here is adjacent, which means so it's adjacent to this line, so we call it adjacent. Okay? And then the slopey one has a very nice and weird name called hypotenuse. Hypotenuse. You could check the spellings later. Hypotenuse. Okay? So it basically means that, what does it mean? Pythagoras came up with a theory, and he said that short courses are shorter than curved courses. What does he mean by that? He was basically saying that if I want to move from y to x, there are two ways to go about that. The very first way, which is a very long one, is moving from what? Y to z, then z to x. That is a curved course. But if I have a straight course to move from y to x, that is what? A shorter course, okay? So he came up with this theory that what? Straight courses or straight path, okay? Straight path are shorter compared to curved paths. You can apply it in your daily life. When you are going home and you go straight road home, you spend less time on the road. If there's no traffic, you spend less fuel. But if you are going and you have to dodge traffic and all that, you realize that by the time you get home, your fuel gauge is down. Okay, so that's Pythagoras for you. Now he also went ahead to say that if I want to find the length of the hypotenuse, which is the slopey part of the right angle triangle, it should be equal to, okay, the square of that. So the square of the hypotenuse should be equal to the square of the opposites plus the square of the adjacent. We know that these are opposite, we know that these are adjacent, and then the slope. Okay, so relating what I just wrote here, if I want to write it well in terms of the labelings of the diagram, hypotenuse is going to be yx, whether x, y, yx is the same thing, the square of it is equal to the square of the yz, okay, yz, and the square of the xz, okay. Now when we look at this equation carefully, we have our yx to be 13, so we can say 13 squared. We have our yz to be 5, so we can say 5 squared, but we don't have our xz. It is the xz that we should find. Okay, so finding the xz, basically we would have it to be x because we don't know that portion. Then now we are going to go ahead and solve this. Okay, I'm going to go ahead and then solve this quickly. Now solving this quickly, 13 squared basically means 13 times what? 13, which will give us 169. Please, you should be mastering your perfect squares, okay? Because it's very important. If they want to disturb you during the BECE, they'll bring those perfect squares and other things, so that those who have not mastered it will struggle a bit, okay? So please master it, okay? Please master it. Now, if I do that, then it means this is going to be 169. And then This also means 5 times 5, which is obviously 25. That's a perfect square, you should never forget. So that will be 25. And then we have x. So this gives us a very simple linear equation. The simple linear equation in the sense that we just have to find the value of what x. So we have to push the 25 away. So doing that, remember the value of x, there should be a square because this also had a square, so don't forget. Okay, so doing that, we'll have 169 minus 25 because the 25 here is positive. So when it comes to this side, it's going to be negative. And we have our x squared. Okay, let's continue. When we do our subtraction, we should have 144. Yes, 144 and x squared. Now we want the value of the line. The value of the line, because it's not an area, it can't have a square. So we need to get rid of the x, which is there. Okay, we need to get rid of the square, which is here. This is what I'm talking about, the square. We need to get rid of it. That has to be what we call standard form. Okay, so 1 minute to copy. 1 minute to copy. 1 minute to copy. And if you are not that fast in copying, you can just take a snap shot or a screenshot of whatever is on the screen. If you are using your phone, it's easy to do that. If you are using your laptop, you press and hold Fn, and then you press the portion that says PRTSCR. Okay, so let's quickly do that. Okay, so that is up. So we are moving on to standard form. On to standard form. And standard form, same on BECE 2003. Okay, BECE 2003. The question says, let me read the question. The question says, simplify 6.4 times 0.25 times 16, all divided by 0.08 times 0.5, leaving your answer in standard form. That's a statement you need to take note of. So let me write the question on the board quickly. So simplify 6.4 times 0.25 times 1.6, all divided by 0.08 times 0.5. Okay, so let me explain quickly what standard form means. So standard form, if I have 0.048, scientists will be dealing with large values, especially the value of the speed of light. Okay, the value of the speed of light it has a lot of zeros. I think it's about 1 million or something. Okay, so dealing with that kind of value, they don't want to be writing that number of zeros every day. So they came up with a way to write the numbers. So if I have, let's say, 1, 2, 3, comma, okay, and then I want to write a standard form for this. It becomes 3 times 10, raised to the power the number of times I'm going to flip to get to the 3. Okay, so 1, 2, 3, 4, 5. Okay, I flipped 5 times, so it becomes 5. But take note, we use the charge, the power here, whether it's going to be negative or positive, we use the number line to determine. You know, on this side of the places you've jumped or the number of flips you've done to get rid of a decimal or to move a decimal from one place to the other. And as I said, the direction or the charge for the power is determined by the direction in which you are flipping. So you are flipping to the right hand side of the number line. We all know how the number line is. So if I said you are flipping to the right hand side of a number line, it basically means if you are flipping to where the positives are, then your charge should be negative. If you are flipping to where the negatives are, which is the left, then your charge should be positive. Okay, so that's just by the way. So we are going to change all this into standard form. Okay, we're going to change all this to standard form, and standard form helps us to working with decimals. I know most students have difficulty with working with decimals. So with standard form, it helps us get rid of the decimal points in without changing the values. Okay, so this 6.4, we can write it as 64 times 10. So it means that I'm just flipping the decimal out, times 10. What direction did I flip to? I flipped to the positive, okay, the right hand side. So it means my charge should be negative. So it becomes negative 1. Okay, then I do my multiplication. I don't want 0.25. I'll prefer 25 because it will be easier to work with 25. So it means I'll be flipping 1, 2 to get 25, right? Now flipping 1, 2 to get 25, I'll write my 25 here, then I have times 10. Now to know then times 10 raised to the power is the number of times I flipped, so that will be 2. Now to know the charge, whether this 2 is going to be negative or positive, I was flipping towards the positive, okay? Flipping towards the right hand side. So it means my charge is also going to be negative. And then we are not going to do anything to the 16. 16 is actually easy to work with, so we'll leave it that way. Okay? Sometimes they bring the numbers that you're not supposed to do anything to, so that it confuses you. So because someone will try tempering with a 16 and go and get a decimal, and then the person will get confused. So when you realize that it's a rational number, don't do anything to it. Okay, so we have 0.08. We don't want to work with 0.08. We want to work with 8. So we are going to flip how many times? 1, 2. So it comes what? 8 times 10 raised to the power 2. Which direction are we flipping to? We're flipping to the right hand side. So that's positive. Sorry, that's negative. Sorry, I was reading a comment. So I got a bit distracted. Let's move on. Now we want to multiply. Now we have 0.5. 0.5, we don't want to work with 0.5. We want to work with 5, right? So working with 5, we want to flip so that the decimal goes away. So we'll have 5. How many times did we flip? Once. So it raised to the power 1. What direction did we flip to? We flipped to the positive on the number line. So that will give us a negative. Okay, so now that we've done this, we are going to build our knowledge of indices, which is powers of numbers, to solve this. Don't worry, it looks a bit scary, it looks too complicated, but all we need to do is to just group all the things with their powers together, and then we'll group all the numbers, the simple numbers, also together. Okay, so in order to do that, we'll have 64. Remember, we can group them easily because it is multiplication that is the operation here, and multiplication is commutative, so grouping them, we won't have an issue at all. So times what? We bring the 25 and then times 16, okay? And then the powers, the ones with the powers will come, so 10 minus 1 times what? 10 minus negative 2. Sorry, raised to the power negative 2, I should say. And then we also do this 8 times 5, okay? And then times 10 raised to the power negative 2 times 10 raised to the power negative 1. So having this, we basically have to simplify. This is a multiplication here, multiplication operation here. So we basically have to try and simplify. The division will help us divide. So let's try and see if we can do that simplification quickly. This 8 will go into this once, to go here twice. And then 5 will go here 1, 5 will go here 5. So let's rewrite this nicely. So 64, 5 times 2. Then we'll bring our powers. We'll be working on the the ones with the powers very soon. So all this is gone. Okay, so it becomes 1 minus 2. They are all 1, 1 now. The 8 has become 1 because we cancelled it with the 16. The 5 has also become 1 because we cancelled it with the 25. Now, it's not, because it's multiplication, it's not really relevant to write the 1 there. Unless, of course, you want to carry the 1 along till you finish. Okay? But since it's just 1, 1, we can just ignore it and write the 1 step there. So we have negative, raised to the power negative 1. Okay. So having this, we can quickly do the calculation for this. This will give us 10. 10 times 64 should give us 640. Okay? So we'll have 640 times 10 raised to the power negative 1 times 10 raised to the power negative 2. And then we'll have 10 raised to the power negative 2, 10 raised to the power negative 1. So let's go deep to look at how to solve this. So to look at how to solve this, we are going to use indices, okay, which is the same as powers of numbers. Okay? So to look at powers of numbers, basically, remember when we have a raised to the power b times a raised to the power c, once the base numbers are the same and it is multiplication between the base numbers, the powers will add. Okay, so this can be written as what? A negative b plus into brackets negative c. Okay, so it's the same principle we are going to apply here. It's the same principle we are going to apply here. So in order to solve that, let me bring this here quickly. So we'll maintain our 64, and then this will mean that we'll have 10 raised to the power negative 1 plus into brackets negative 2. We are doing the same thing to what is down there. Okay, so that will be what? 10 raised to the power negative 2 plus into bracket negative 1. Remember, I said that when you have a raised to the power, even if it is not negative, if you have maybe x raised to the power 2 times x raised to the power 4, because the base numbers are the same. This is just revision. I know most of you know this, but I just want to go over it. Okay? When you have the base numbers being the same, the powers would add. Okay? So it means this would be x raised to the power 6. Okay? So it's the same principle we are applying here. Now, this means that you owe 1 CD and then you owe someone 2 CD. Negative means you owe. So in all, it means you'll be owing 3 CDs. Okay, so it will be 640 times 10 raised to the power negative 3. All divided by the same principle applies here. You owe 2 CDs and then you owe someone 1 CD. So in all, it means you'll be owing 3 CDs also. Why negative? Because you owe. Okay, so let's move on. Now when we look at this closely, look at this too closely, they are the same. And it is division that's between them. And the operation sign is multiplication. So it means that we can actually cancel. So this, then it goes off. So now we have 64 as our answer. But remember, the question stated that we should leave our answer in a standard form, which means that we should write it and it should end with something like this. So in order to do that, Remember, every number without a decimal point, the decimal point is after the last digit. Okay, so it means the decimal point is here, so we're going to flip. So we have 1, 2, which will give us 6.50. We can ignore the 0. Okay, times 10. How many times did we flip? 2. 2 times. What direction we're moving towards? We're moving towards the negative, so our charge will be positive. If you want to do 6.4, you can do 64 times 10 raised to the power 1, but that won't be so significant as standard form compared to 6.4, okay, times 10 raised to the power 2. Are we okay? Standard form, most of the time we are expecting that it will be in the decimals. Okay, so we can't do 64 times 10 raised to the power 2, times 10 raised to the power 1, if I should say. Okay, so that is it about standard form. That is it about standard form. We want to quickly look at statistics. Statistics, and then we'll end our lesson. I want to quickly look at statistics, and then we'll end our lesson. But 1 minute to copy, so please quickly copy this. Copy this quickly so that we can look at statistics for BECE 2003, I think April. Yesterday we looked at BECE 2017. We were not able to finish. There was left one question that I wanted us to look at, which was angles. So I'm hoping that my data will not misbehave. If my data doesn't misbehave, then we can look at that one also, and then we'll call it a day. Remember, this class is always 10 a.m. GMT every single day except for weekends. Every single day except for weekends. But for all you know, I might decide to do a class or have a class on Saturday. A Sunday is out. Okay? So whilst you copy, please take notes. This is my website, thinkacademics.com. Go there, there are courses there, there's BECE mock there, there's a lot of materials there, and most of these materials is a new site. It was just built by me. That was last week. Okay, so it just went live this week. We are still trying to put new materials there. We are trying to mount our courses and everything. So we are hoping that by the end of next week it should be fully functional. Okay, some courses will be free, some courses will be paid. We have courses from Bible lessons to auditing to Excel, web design, drawing, etc. That will be mounted on the platform very, very soon. Okay, so please register because there's a giveaway package for the first 20 students who register. Then don't forget to subscribe to the channel. Don't forget to like the video. That is just to encourage me to do more, okay? That is just to encourage me to do more. And the more you like and subscribe, the more other students will also get to see the channel anytime they are on YouTube, and then they also get to benefit, okay? So let's stay tuned. Now let's quickly look at the statistics question. Quickly look at the statistics question. Now the statistics question, we have a nice table. And remember, statistics, when they give you the table, it means you don't need to do your tally. But when they give you the mean age. And please take note, once they are saying modal age, mean age, you shouldn't just write mean equals this. You should qualify it with whatever they are saying. So modal age, you should bring years, okay? You don't just leave it that way and say modal age is 1, so 1 modal age equals 1. No, please. Then we have B. They are saying we should draw a bar chart for the distribution below. Unfortunately, we don't have a graph, but I'm going to quickly explain how to do the bar graph. Okay, so draw a bar graph. some call this bar chart, so it's fine. Then the C says that what is the probability of choosing at random a child with age 4? We'll talk about that. So let's quickly spring into action. So the very first one, which is the AI, so let me write solution. So AI. The AI basically, you just have to go to the table and get it, because this one they've actually done the table for us. We don't need to do the tally and find the frequency before we can get the modal. Modal basically means, well, which age has a large number of children. Okay, so 1 year old, 2 year olds, 3 year olds, 4 year olds, 5 year olds. More. Okay, so technically we would have 6, which is the highest frequency, which will be pointing to 1. So we'll state that the modal age is 1 year. Okay? When it comes to statistics and anything that has to do with word problem, do not leave your answer. Let's say you are solving it. Maybe it is algebraic equations, which word problems involving algebraic equations, and you solved it, then you found your x, and then you leave your x as x equals 5. You need to write a statement, because now the examiners and the marking scheme, when you don't write your statements when it is a word problem, marks are deducted. This goes to all the BECE students. Marks are deducted. Okay, so please, let's take note and then do that when we are writing our exam. So remember, the frequency 6 is the highest, but that doesn't mean that's the modal age. The modal age 6 is in reference towards the age 1. Okay, so we've written that. Now let's find the mean. The mean, to solve the mean for a grouped data. What do I mean by a group data? A data that's, okay, we've actually gathered, we've done a tally and all that, okay? For that particular data, it's not raw. So to find the mean, we have to use the formula mean. Mean. Now, the symbol for mean is x and on top. So to find the mean is sigma fx over sigma f. Sigma here means total. Okay, so we are going to do a frequency table. For this data. Okay, so frequency table for this particular data. Our frequency table, we need the age, which represents our x. We need the frequency. Remember, we don't need the tally because it is not raw data. And then we need the fx. So this is the fx, this is the frequency, and this is our age, which is what x. Frequency and then fx. Okay, I'll explain what the fx means soon. So doing that, we are going to fix in the age. So please, it is always sigma fx over sigma f. Are we okay? And then we found our value. We have 57 over 20. Okay, 57 over 20. And then to solve that long division, you do your long division. 20, 57, 20 will go there. Okay, so that's 2. We've got 42 points. Okay, 8, 5. Remember, mean age. So you just don't write 2.85. It is 2.85 years. Okay, 2.85 years. Now let's come to the graph. The graph, a bar graph. Okay, a bar graph. Frequency is always at this side. okay? Because we want to measure it, okay? So the values for the frequency will determine whether you're going to make it in multiples of 2, in multiples of 1, in multiples of 5. But with this value, I think the highest is 6, so we can do multiples of 1. So 1, 2, 3, 4, 5, 6. This side should be our age, which is x, okay? Now, the frequency, you should have the same interval between the bars. The same interval between the bars. So if this is the first bar, this is age 1, right? Which is 6. You don't write the 6 here. You don't write the 6 here, but you write it in the middle of the... Sorry, you don't write the age. You don't write the age there at the beginning of the bar. You don't write the age at the beginning, at the end of the bar, but it should be in the middle. So this is age 1. The same interval from the beginning to the side should be the same interval here. Okay? Should be the same interval. Yeah. So we want to do for 2. I can't do for all of them. I'm just trying to explain how it works. Okay? Same interval, same size of the bar. The bar size should be the same. You can't use 2 centimeters, which is a full box, to do 1 bar. Then you decide to use half box, which is just 1 centimeter off on the graph paper, to do the next bar. The bars are supposed to be the same, the intervals are supposed to be the same. Okay? And then the labels of the bar, which is the A, which is down there, should be at the middle of the bar. Okay? So having that, we would have H2. H2, the frequency is 4. Okay? So where is 4? 4 is somewhere here. I see a lot of richer school form 3s joining. That's good. We have this class every single day. Okay? We have every single day. We have this class at 10 in the morning, sharp. 10 a.m. I'm starting. So please try and be on time so that whatever we are doing, you not get lost in the process. This basically is just a prep tutorial for BECE candidates. Aside that, once you love math, you do math in school, you are free to join. Most of the Form 3s are joining now. I'm happy about that. The Form 2s are always here, which is very good. Okay? So basically, that's how you do your bar charts. Sometimes they call it bar graph. Okay? Same bar size, same intervals. The frequency is on the vertical because you are trying to measure how tall the bars are. And then at the down part is the label to identify this bar. Okay, this bar belongs to age 2 or this bar belongs to age 5. Okay? Now, if you are doing any experience or you experience a challenge that the number of bars will not fit, you reduce the size of the bars, okay, from the beginning. So you have to do what we call counting. I'll try and do a video on that, on how to go about drawing the bar graph. Okay, I'll try and do a video on that. So that will bring us to the end of this question. There was another question that was given under this, and it reads as, what is the probability that a child chosen from the school is 4 years old? So the probability, basically, the child chosen from the school, how many children were 4 years? 3. What is the total number of children in the school? 20. So the probability is going to be 3 over what? 20. Okay? The probability is going to be 3 over 20. Now, when you get a probability, if you can reduce it. Okay? But what we have on the board, we can't. Okay? We can't. So we'll leave it that way. Are we okay? We'll leave it that way. So let's take our very last question, and then we'll call it a day. If you are now coming, you can copy the question. So 1 minute to copy. 1 minute to copy quickly, and then we'll call it a day. From next week, we'll be looking at construction. Okay, we're looking at construction. I'm trying to get software that will help me draw on the board. So we're looking at construction from next week. Okay, so let's move to the last one. The last one is angles. Okay, the last one, angles, and then it's June 2016. So June 2016 question, BECE. Okay, so I'll just be picking the questions random. Okay, random questions, and then we'll solve June 2016 objective question 31. Okay. We have 2x plus minus 10, sorry, is in a bracket, and then there's a degrees here. We have this mark. Okay. So let's quickly revise triangles in plane geometry. Triangles in plane geometry. Now, if I have this is an isosceles triangle. Why? Because the mark there tells me that this line, this side and this side are equal. If I have now, I have one mark here, I have two mark here, I have three mark here. It basically means that no side is equal because the marks on the lines are not equal. Okay? So let's quickly look at this. Now, when we look at this carefully, we realize that we have the same mark, one stripes on each of the side of the triangle, which tells us that this is what? An equilateral triangle. Equilateral triangle, remember the total angle in a triangle should be 180 degrees. Okay, so if this stripes on the sides of the triangle says that they are equal, it means that if I put A here, A will also be here, A will also be here. How many A's do I have? 3 of them, right? But if I sum all this A up, it should give me 180. We are trying to find the angles inside, okay? So this will give us 3A equals 180 degrees. And then when we divide, we are going to get 60. Okay, so every equilateral triangle, the angles in them is just 60, 60, 60 across. Okay, so 60. Basically, why do we even need the A? So that we can do supplementary angles with this. So we can do supplementary angles with that. Okay. So doing supplementary angles, it basically means that 10 degrees and then 60 degrees, 60 degrees, 60 degrees. Okay? So it means this, from this particular principle, it means 60 plus 60 should be equal to this. So 60 plus 60 equals, into bracket, 2x minus 10. Okay, we can remove the bracket because we assume it's 1 here, we use 1 to expand. There's no other 10 there, so we can remove the bracket. Equals 2x minus 10. 60 plus 60 should give us 120, 2x minus 10. Now we're going to move the 10 to the side, so it becomes 60 plus 60, which is 120 plus 10, because it's negative. Okay, this gives us 130, 2x. We divide both sides by 2, And so this will give us cosmetic mathematics. We bring the variable to, remember it's degrees, so you try and write your degrees. So this brings us to the end of today's lesson. Please stay tuned for tomorrow. Tomorrow we are starting at 10 a.m. in the morning. Please don't be late. And then try and register on my website, thinkacademics.com. There are courses there, there are mock questions you can try, there are timed quiz questions, especially for math, that you can try, and all this will be available by next week, the end of next week. But you can register because the first 20 students that are registered to the site will have a free giveaway. So register at thinkacademics.com. Okay, thinkacademics.com. By the end of this month, we should have most of the BECE courses on that platform, which you can take and learn anywhere at any time. I wish you the very best and make use of today. Have a nice day.